Okay guys, so I just came in from out in the shop and I did something I hope never to do again. I took a barrel, a gun that was already threaded, already timed, already chambered, and I stuck it back in, not to try find my original setup, but because I screwed up. I was videotaping a sequence. I did something that is classic for me. I doubt that anybody else will understand it. But anyway, I'm going to run this. I'm going to point this down to my paper down below, and I'm going to draw some pictures for you. Try to explain what we just did. Basically, I did a barreling job and a timing job, indexing, Gordying, whatever the term is that we want to use and settle on. And as always, when I'm doing this, I'm not only in a rush, but I'm distracted by the whole filming thing. So, because of that, I made a mistake. I'm coming down, I'm chambering away, I'm showing off my pusher method, I'm showing what I'm doing, and I hit a target 30 thousandths away. I hit it right on 7 thou, which is what my target was. It's in the video, that's what I was going for. I went 30 thou, hit right on, put a 7,000 feeler gauge in there, tightened it up, it stayed there, then I pulled it out. I mean, to me, that's right on 7 thou. But when I chamber, that's not close enough for me. I can chamber 20 chambers within a thou, but within that thousandth is where I want to get my final fit on my chamber. So I final chamber right here in this, oh, you can't even see this little vise, but anyway, I final chamber in here. I popped the last couple little bit out of my chambers and I fit them to a whole line of barrels. Whatever guns I have up and running, I do a comparison and I get all the feel exactly the same. So my brass will literally go from one gun to another. And literally, if there is a human hair present in the system, it'll lock up like bolt won't even start to go down. If there's a mote of dust, if there's the tiniest thing, fitted dies, fitted chambers, identical chambers. But, long story short, I hit my 7 thou, and for some reason, because I'm a turd head, I managed to convince myself that, yep, we're close enough, because when I tighten this thing down, I'm going to grab another couple, 3 or 4 thou, and we're going to be down to 2 or 3 thou, and then I'll do the rest in the other room. Well, because I'm dumb like that, I didn't realize I was going the wrong way. If I had gone 2 or 3 thou over, then when I tightened it up, I might have got it back. But I was 7 thousandths short of chamber. Now when I tighten it up, I'm going to lose another. I'm going to be 10 thou short. And my timing was 10 thou short. Both of those, I wanted to time up here, I timed over here, and I thought, you know, I should screw this thing together, chamber it up, and shoot it with the barrel pointed sideways, and then come up and shoot it, and then come up 3, and I'm going 3 setups. That is bogus. No, forget all that. I decided to take it a totally different way. I decided to take this finished barrel out, that I finished out in another video, and put it back in the lathe and see if it comes back. And I couldn't use the same section of bore this time. And I'm going to try to come around where maybe I can draw this so that it makes sense. If we presume that a bore has got a bend in it, in this case I presumed that the bore had a bend in it, and I used it this direction because I was setting it high on this end. And I took a section of bore. This is where I pivoted in my chuck, and this was the end of the barrel. And I took this section of bore right here, pivot in the chuck, 1.5 inches in, back at the face of the bore, and I set this up, and my barrel ended up 40 thou high. So if you're referencing a video, look for 40 thou high. This barrel is in there flopping up and down and well, it's 20 thou high, but it's showing 40 thousandths of movement. So the end of this barrel is 20 thousandths higher than I set these 2 points. Now I threaded, tenured, chambered. Did this work? And I pussed it up, people. I screwed it up. I ran it too short. So I said, you know, you machinists are going to hate me for this, but I just went back out and put it back in the lathe. And I indexed it with a Gordy rod using another section. I set the pivot here now. Different pivot. I don't know what this board's doing. It could be doing all. But I took this, and I set this barrel back in using these pivot points. I used the mouth of the chamber. I used my new pivot point. And I used a pivot point out here. And I took this section of the banana and I dialed it all back in from this side. And then I whipped around with the camera and I showed you this end. And you can draw your own conclusions from what we saw. We did not come back to exactly where we were in the first setup. Now, in a perfect world, with a perfect piece of stock, and with all the planets and stars in alignment, in my non-temperature controlled shop, the thought of me taking a piece of stock of any sort, and this is why, so far I've tried 3 different abortive attempts at turning necks on the lathe. I've tried 2 calibers and 2 necking down methods, and they've both sucked. They haven't worked. I feel that I need to blow out that brass and harden those necks. So that's where I'm at now. I've got them loaded up. I'm ready. I just have to keep getting sidelined here. I'm ready to blow those out, go out. But the reason that's relevant is because every time I do that, I have to return. I throw a piece of stock in the lathe and make a new mandrel. First of all, when I walk in the shop, I flip the thing on, I flip all the heats and lights on, and I walk around, I'm getting everything set up for 20 minutes. I just let that lathe sit there and cook. I come back, and I make a mandrel, and I set all of my numbers from scratch. And now, I can feel that the center line is as close as this lathe can hew to a center line. Close enough. I mean, for brass, you can't, with all the conventional measuring methods, you can't measure any run out in it. So, that's where we're going with this. But, and I do that because of the fact that here I have a nicely built mandrel. I polish it off and everything. I've tried that. I've got one polished, I got one 320, I got one left rough, I got trying different things. But I'm thinking, you get a really good mandrel, boy, it'd be really nice to use that again. Bag that. I could never get it back in where I wanted. If it's a no, I cannot do it. So I just make a new one each time. So the idea of putting this back in, my parameters were, if I got within 20% anywhere, I ended up dialing this pivot point where the lathe chuck sits and the back of the chamber that I had cut. And I got them back down into where I could get less than a line of wobble here and less than a line of wobble here, which on that, I don't remember, that's a MAR indicator, I guess. They purport it to be 5 millions, but I don't care about all that. The point is, it had a pretty long stylus on it, but it was reading just between 2 lines. It was, you know, back and forth in between 2 lines. Call it a half a tenth, call it an elephant's butt. It doesn't matter to me. It was pretty tight here. It was pretty tight here. I went back out here and be dad burned if I didn't real close to getting my 40 thou back. Now, did that prove anything? I had a thou of wobble right here. But I took this piece right here. I used a much shorter section. I had a choice to make. I could either go point to point 3 inches apart, or I could just go point to point, because I used to have, remember, I used a point out here that doesn't exist anymore. I cut the chamber out. I used a point out here, a point here for a swivel, and a point in here. I aligned this section of the bore. Now I moved down the bore 2 solid inches, the full length of this chamber plus the amount that I trimmed off the back. and I aligned this using just that little section and the back of the chamber. Because to me, what was more important in this setup was kind of getting it back. So I had a check, and I had a needle of wobble out here. And I was inside, so I went bam, 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 call that 3 points. And I got back my 38 thousandths out there on the end. And this time it was like 2 degrees off. So I did that because I'm going to go back and use my pusher and punch that chamber in. I didn't want to sit here and try to grind out 10 thousandths And plus, I don't know that I could do that without inducing some runout. So, that was just an explanation of what we just did, how I picked my points. And now I'm going to go fit that barrel correctly. Hopefully, at one point, go back to our video with my cheat sheets here about, I was talking earlier about explaining ballistics to you. Because this is fascinating stuff, guys. This is just mind-blowing, cool stuff. And everything that you hear out there is crap. So, how do you separate the crap? That's what we're talking about here. We're going to apply some actual numbers. We're going to do some actual builds. We're going to shoot at some actual target, but that's not enough. I could be faking that. You know, movie magic has existed since there were movies. Disney's been fooling us people. This isn't about fooling. This is about getting you interested enough to check this stuff out on your own. First of all, go to a bench rest match. Go somewhere and watch what's actually being done. I'm in construction. I've got at last count 17 laser transits. I don't buy expensive laser transits because I'm in normally shooting within 100, 200 feet either direction. When you have to move the transit, we do. But the point is, I buy up to about $3,000 units, and we always have a total station on the job, and for some of you that'll mean something, and if it's a big job we have access to. But the bottom line is that an optical transit is as accurate as the bearings it sits on and the aberrations in the air. A laser transit is I have a dozen guns that are inherently more accurate than my laser transits. All of them. Laser transits have some good things, they have some bad things. When I say bad, no, they work within a set of parameters that's actually less accurate than this gun that I'm attempting to build right now. Well, that I'm gonna build. I shoot bench rest guns. I own bench rest guns. I have had bench rest guns built by true bench rest gunsmiths. And I need to say that with a big capital B. There aren't very many of them. If you want to see actual, real accuracy, people, you find yourself a bench rest match with a big B. You find yourself a bench rest gunsmith with a big B. One who is currently building, some of them are building actions, some of them are just building guns. There are only a dozen actions in the world, and there are only a few dozen smiths in the world that do bench rest. But if you want to see accuracy, people, if you want to see guns that are more accurate than a laser transit, prepare to have your clock reset, people. Seriously. Do this. We're going to try to do that here, but again, it could be all faked. It could be just another U-Bubble channel where some guy is trying to say, no, I had nothing to sell. That's the one thing here. You can say, oh, you can say what you want. I don't care. We can speculate all kinds of things. I will do my best to get you interested enough to go out and try this stuff yourself, people. That is my goal. Go out, experience this for yourself. And then do experiments. Do whatever you've got to do. Join the ranks, because this is the bleeding edge. This is the cutting edge of accuracy in the world. Big B, bench rest, dig it.